I'm gonna start with a story here. I like it because it's true. So imagine you're in a shower, right? You love the place because it's quiet, you get all your best ideas there, you solve issues. But then you realize that the shower head is leaking. So the moment is gone. You're pissed off, right? But you know nothing about home repair, but you're on a mission to fix that, right? So what options have you got? So one option would be to go to the good old store there. So you get dressed, hopefully, and you go to the shop. And if it's one of those large stores, in Poland at least, you actually need to chase down the assistant. Well, first, maybe ambush them in an alley, but once you get their attention, they are generally pretty helpful. And what happens is the conversation there, and let's think about it a little bit. In general, you will describe your problem there. Either specifically what you're looking for, if you know, but since you're clueless about home repairs, you might describe the symptoms there. And then there goes the first problem that Charlie actually mentioned, the vocabulary gap. So you describe the problem as you know it, right? Not necessarily how the product is indexed in shop assistant's head, but he will or she will translate it. Then there's typically a series of questions, right? And let's focus on them a little bit here, because they are important here. They are not arbitrary. What the shop assistant will try to sort of elicit from you with these questions are two things. First of all, what are the hard constraints, right? Things that, like products that you are disqualified straight away. Say, if you're like looking for shoes and you're size 42, like me, well, you wouldn't buy size 44 no matter how cool the shoes are. So that's one thing. And the other thing is to narrow down the search, right? The catalog. And this is like a little bit more tractable in terms of the model. There are actually quite many stores that do that already. They can use things like entropy or some other diversity measure just to basically ask you the right question, the right attribute. You don't want to ask too many questions because, well, you will piss off the customer, right? You just want to get things sorted quickly. So let's compare this with online. Right, so this is a variant of a slide that has already appeared in René's talk. I'm talking about e-commerce here. This is sort of our domain. So you typically see something like this, right? You have a customer. They may start typing somewhere over here, and you see pretty much everything that search UX industry came up with in the last 20 years here. So you have autocomplete, right? Type ahead so that you don't have to type so many keywords, so many keys, but also to guide you, right? Through what is available in the product catalog. So that's the first one. Some suggestions may pop up straight away there. Then you have like search results, typically with facets, just to give you some summary of the results, so that you have some idea, what you can choose from, what are the main clusters, groups, etc. And then finally, you've got the product. So that's this thing. Now, in e-commerce, actually, when you look at the data, and we happen to have plenty of it because we've got well over 1,000 shops to look at. There's quite a lot of traffic that goes directly to category and product pages, and that is a huge problem for these sites, because what happens is they bypass that search part completely because it doesn't work as good as Google, for instance, or they just came from some paid campaign. They jump in, see what's there, and they jump out. There's no brand loyalty whatsoever there, right? And that is a bit of a trap, especially in sort of medium-size e-commerce segment. Now, there is an important part here. Most of the things that I described were sort of invented, 15, maybe 10 years ago in terms of this UX sort of helpers. But right now, at least our sample indicates that at least on average 75% of the traffic is mobile. There are some industries that it goes as high up as 80%. So there are two things that matter. Okay. The screen size is the first one. This is actually up to scale. This is my laptop and this is my phone, right? So the amount of sort of screen estate that you've got is much, much smaller. That means that it is extremely tough to build a UI interface that allows you to browse through the results, using those filters and facets. Sometimes choosing a filter that seems like filling in like tax, return form. You have the whole thing here, sort of, the whole product page is hidden, or the results are not visible at all. And the other problem here is the keyboard, right? So there's a rumor that in 2007, some journalists asked Steve Jobs, about this thing, and said that it's very inconvenient to type. And Steve looked at him, smiled, and said, "You will get used to that." And I think we did get used to that, although not quite. And what I mean by that is that, again, if you look at the numbers, our sample, of the shops that are integrated, you will see there's up to 30% of difference in terms of numbers of keys that are typed, like keystrokes that we measured. This keyboard is just, not very convenient for typing. So, right. I think I'll do this old school. Okay, so we've got typing, which is slow, and we've got touch on the mobile phone. So from now on, we'll focus on mobile devices only, right? And touch is extremely fast, right? As long as you have the right thing in front of you, you don't have to actually, go deep down and search those things through filters and categories. So the question is now, what happens if you consider speech, right? And that is the thing I mentioned, that a few years ago there was a lot of sort of things, breakthroughs in NLPs, in natural language processing, and so we started thinking about that. So speech is faster. How much faster? Well, here's a graph again from our test. So what you can see here is the number of words that users uttered, and then there's the seconds. Now this is end-to-end ASR duration. So that means that there's a bit of a time from the moment the user realizes that they can speak, and then ASRs have this concept of endpoint detection. So they need to figure out basically, when to stop listening. And they have many strategies for that. One way to amortize that time is actually to have two thresholds and some more complex solutions to that. So what happens basically is as soon as ASR gets a little bit confident that this may be end, it fires the request to the backend, and then it waits for another maybe 100 or 200 milliseconds, and just to get sort of the final confirmation that it's really the end. And sort of the advantage of that is that some things are pre-computed already. So, right, so speaking of ASRs, this is the sort of a poster child for neural networks in terms of success. This was one of the sort of main things where you could really see the difference as soon as deep neural networks were, introduced. So what you've got here is the word error rate. It's sort of like a standard measure, metric used to evaluate them, and you see a consistent sort of drop. So this ends around. That should be, sorry. That's from more or less 2012 up to 2019. The horizontal axis there, and well, the thing is that it actually exceeds the human level. Now, as with all this kind of statistics, the devil is in the details. This is a test set. Switchboard, if I remember correctly, that's one of the classic ones. If you ever used ASR, you know that they are not as good as humans just yet, right? They made various kind of mistakes, and it depends on the sort of background noise that you've got, on your accent, maybe echo, reverberation, and this kind of things. Also, the type of error matters, right? So it's a very different story for the search system if ASR drops the 4 here compared to dropping the word red or misunderstanding it, right? So here are sort of 2 examples what kind of issues we came across, with ASR systems. So these are mostly around homophones, so words that sound very similar to each other or even the same, but actually mean very different things, right? So for a search system, sort by color, so 2 colors, is a very different intention that sorting by color the existing result set. The other one would be this one actually. So you're looking for a bat, right? A baseball bat here, and this is the transcription that we got there. Right. So one approach to solve this kind of things is biasing the model towards certain words, and this is especially important in e-commerce because many things like brand names that people are looking for are not that common statistically, right? So what you want is to impact the probability distribution there, and depending on the model, it can be easy, right? If it's a hybrid model where language model is a separate component from acoustic model, or this can be quite hard if it's end-to-end neural model. So that's one thing. You can also do this sort of post hoc. So after the transcription, if the only thing ASR gives you is just that word, show me a but, right? You can figure out that you're in this domain and just basically sort of autocorrect it like a spell checker would do, but not on the individual characters, but on a word level here, right? Right, the problem with ASR is that it gives you a transcription there, but like it doesn't understand whatever understand would mean here, what's behind. So it doesn't know that red is a color, right? That it's an attribute that it should search. And here what we really want when user says something is this, right? So this is an example of a sort of longer phrase here. And you can see there is a lot packed into that, right? So you've got intention. Typically in e-commerce that would be search, but not always. Maybe somebody's interested in returns, right? Or tracking their product wherever it is, right? And you have the series of attributes there, color, style, gender, and so on, and et cetera, et cetera. So this is what you want to get, right? And this has a name. This is called, entity recognition, right? If you think about like modern search, you would typically hear these 3 concepts these days. So there's a full text search, typically some variant of BM25. So it still works exceptionally well for short keywords. It's a very strong baseline, right? But it would not solve this problem at all, right? It wouldn't handle that. There's the entity recognition approach where you take the query and you actually put a lot of processing on that, trying to rephrase it so that it's more like a structured query, and then off you go to your product catalog. And then also you have a vector search that I know that Atita and Zbyszko will be talking about, which in our experience, so that I guess I can share, is it actually made more sense to use it sort of internally rather than just to replace, say, full text search. So the problem with vector search that we experienced is that sometimes it gives very precise results, but sometimes it goes completely off the tangent, and it's very difficult to steer that. Okay, so right. So this is an example of one of the UIs that we've had, and you see the the attributes extracted there from the user utterance. So here are a couple of examples why NLU is hard, right? So basically it's all around ambiguity, right? How do you, the meaning is very often in the context, right? So in this example, the pounds can either mean like the weight of the product, or it can mean the currency, right? And it is a non-trivial task to do something like this. In Polish, an example would be złoty as a color, which means both currency or a color, right? And you can have, you need to somehow disambiguate that part. Okay. A different example would be this thing. This is sort of a classic, right? It's negation handling. So it's quite obvious what the user is looking for here. It's the stripeless shirt, but there's what you actually get if you type something like this into the search engine. Even the big ones is you'll get this result, right? Pretty much all of them have shirts, and this is the problem of negation, and it happens quite a bit in natural language, right? So there could be things, I'm looking for shoes without laces. This is one that we saw, or things like color different than, right? It's basically a very tricky problem in natural language processing. Yet another example here is you're looking for, this was actually new to me, maybe because I don't really, use bags that much, but apparently people are looking for bags that can fit in A4, right? And quite often there's no way for the search engine to understand what A4 means here. So this is an example of real world knowledge that is needed, and actually things like ChatGPT could really help with this kind of problems. We tested this a little bit, and the results are very promising here. Right, so I focus mostly on the query side of the things, but there's a symmetrical part about the content, so the product catalog that you've got. You basically can do quite a lot in terms of description processing, just to extract this kind of thing and then just do the matching. I talked a little bit about sort of the back end, of all of that, but really what you need to start with is the customer experience, okay? And there are some interesting challenges and opportunities here as well, and I'm gonna talk a little bit about. Right, so unlike voice-only solutions like Alexa or maybe Siri, which are activated by a wake word and basically listen to you all the time, this kind of solutions, they need to be somehow activated, at least on the sides, with user pressing on something. And that's a lesson that was quite surprising to me, that how you display that information can have such a huge impact, even a really tiny changes. So depending on how we display the microphone here that you see on the screen, we have a difference of more than order of magnitude in terms of CTR, people interested in clicking that. That is really huge, and it's very easy to dismiss voice search if you just put a microphone icon next to the search bar. People will not click it. The CTR then would be around 1% in our experience, but we managed to get in some cases to 17%, so 17 times larger than that. Now, speaking of microphones, your mobile phones protect you, and it's a good thing. Like the site is not able just to record your audio, just without your consent. So we actually need to get that permission, and that is a bit tricky to do as well. There are obviously APIs for that that browsers expose, but the process right now, at least, maybe these are early days of voice search, it's not entirely clear to the users. Like they don't really understand when they are being recorded, etc. So it's quite important from our experience to explain this well. And there are a couple of sort of things that we tried, like various overlays just before the system dialog here. And this is not just search UX, but in particular in search UX, this is super important to not confuse the user, to make sure that they always understand where they are. This is true for regular search as well. If the search engine does something like query rewriting or expansion, whatever, user needs to be aware of that. Otherwise, they will lose trust, right? And there are many moving parts in here because you've got ASR that may need some contextual biasing, right? So it will actually change a little bit what you said. There is query understanding part that may not get all of the attributes just right, so it will drop some of them, and you need to recover from that gracefully. So this is a huge topic from sort of the UX perspective, how to do this correctly. Okay, and sort of the main benefits that we have seen so far, and we have been tested this in production for a while now, is that you can gather larger context, right? So typically, if you take a look at the distribution of the of the search queries, you will find that most of them in traditional text search are very short, right? And it is sometimes difficult to figure out the intent. That changes when you look at the distribution of spoken queries. They are longer. Okay, so that's the first thing, and they contain quite often more data that you can use. So that's the first part. The second part is you can skip to the relevant filters straight away. Like you can say, hey, I just need red around 400. Whatever like product you're looking for. So you bypass all the process that is needed to find the filters, etc. And finally, you have ability to guide the customer as well. So we can make it a conversation both ways, right? Right now we are doing this with text prompts, but we are planning to experiment with text to speech as well. So. There's a joke that since ChatGPT was released, everybody is an expert on AI now. So I will allow myself a pleasure to say something about that as well. Like I'm in a camp that is very excited about this technology. Clearly, it has issues and limitations, but like it is mind blowing what it can do, and we actually play with it quite a bit. As soon as you get the hang of prompt engineering, like how to prompt it properly, it's amazing. Now, sort of my prediction is that what will be a big breakthrough is a combination of this neural dialogue systems with external information retrieval system with a voice front end. Right? It really makes sense, I think, to use voice there. And as soon as that hits, I think people will just expect this, also just like they expect all search engines to work like Google and have this, have this quality. So this is it. If there are any questions about voice search, I'll be happy to take them. Otherwise, we can discuss this later.
Hi, Piotr. Thank you for your presentation. So my question is, are you using on-device voice to text, to translate to text and then send this text to backend, or you are streaming audio and processing it on the backend?
So we're actually experimenting with a few approaches, and depending on the platform, the transcription happens either on device, and Apple is actually a big fan of that, mainly because of privacy, sort of around that, so that your voice never leaves your device. On other platforms like Android, we actually use external service, ASR, for that. We get back text, and then we work on the text with some confidence level as well, how sure ASR was.
Thank you very much for your talk. I have a question related to the buying decision process. So let's say we're in e-commerce, and if you go to marketing, there's this idea of the buying decision process. So the person recognizes, I have a problem, TV is broken. Then they start gathering information about what's the TV like today, and then start evaluating alternatives and finally take the purchase decision. And my question would be whether you could see a specific place or spot in this path, in this decision process, where voice search is suitable, or is it covering all the process? So if you go back to keyword-based tapped-in search, you would observe that initially, in the earlier stages of the buying decision process, we won't see a lot of searches. Users would just browse because they might not know the vocabulary. And I was wondering how this works with search. So what they express themselves as, oh, I don't know what I'm looking for, but maybe something like that. So what's your observation with that?
Right, so I guess this is more of like exploratory kind of scenario here. And I guess in this case, sort of the way it helps is that if the product catalog is large enough, what we can do is it's the part of filtering those results and narrowing down the choice. So you might have facets for that, but it may not be clear from the user perspective which facets are like the important ones in the process. So in our hand, on the other hand, if we have some, expert knowledge encoded into that, and this may either come from the, shop itself or from the models, like what are the, important attributes when you're looking for a TV. And surprisingly, ChatGPT is excellent in figuring, what would be a good questions to ask. Like we can prompt the user to get their result. It's a slightly different type of interaction that you have right now. In this case, it mainly it's just a little bit more convenient to go through that through that large list here.
Okay, so I guess we can say thank you to Piotr once again with a big round of applause.